Welcome. In this video, let's explore the fundamental design goals of an operating system. An operating system is designed by balancing performance, security, usability, and other critical considerations. Let's dive into each of these aspects to understand why they are important and how they influence the overall design of an OS. Let's start with performance goals. Operating systems must efficiently manage hardware resources to maximize system performance while balancing other design goals. Performance metrics help evaluate how well an OS achieves its goals and where optimizations may be needed. Response time is the time between request submission and the first response. Throughput is the number of tasks completed per unit time. CPU utilization is the percentage of time the CPU is working. Resource management means efficient allocation of memory, input-output, etc. Latency is the delay between action and reaction. Now let's examine security goals. Operating systems must protect system resources and user data from unauthorized access, modification, or destruction while maintaining functionality. Authentication means verifying the identity of users and processes before granting access to system resources, including passwords, biometrics, and multi-factor authentication. Authorization is determining what resources authenticated users can access and what operations they can perform, which is implemented through access control lists and permission systems. Confidentiality means ensuring that sensitive data is only accessible to authorized users and implemented through encryption and secure storage mechanisms. Integrity is preventing unauthorized modification of data and ensuring system components remain unaltered, which is implemented through checksums, digital signatures, and secure boot. Auditing means recording security-relevant events for later inspection and analysis that helps detect intrusions and understand security incidents. Isolation is separating processes and users to prevent interference and contain security breaches, implemented through memory protection, virtualization, and sandboxing. Let's explore usability goals. Operating systems must be designed with the user experience in mind, making complex technology accessible and intuitive. Good usability reduces learning curves, minimizes user errors, and increases productivity while accommodating users with different skill levels and needs. Modern OS designs balance powerful functionality with simplicity of use through thoughtful interface design and user-centered development. User interface should be intuitive, consistent, and responsive interfaces that minimize cognitive load. Consistency means predictable behavior across applications and system functions. Discoverability means features and functions that are easy to find and understand. Configurability means customization options that adapt to different user needs. Accessibility means support for users with diverse abilities and requirements. Let's discuss reliability and stability goals. Operating systems must maintain consistent performance and recover gracefully from failures to ensure dependable operation in all conditions. Considering the reliability features, we have fault tolerance, which is the ability to continue functioning despite hardware or software failures. Error detection are mechanisms to identify problems before they cause system failure. Redundancy are duplicate components or processes to prevent single points of failure. Data integrity ensures data remains accurate and uncorrupted during operations. Predictable behavior are consistent responses to the same inputs and conditions. Recovery mechanisms are checkpointing, which means saving system state at regular intervals to enable recovery. Journaling means recording operations before execution to allow rollback if needed. Process isolation means preventing failures in one process from affecting others. Automatic restart are self-healing capabilities for critical system services. Safe mode is fallback operation with minimal services for troubleshooting. Now let's discuss compatibility and portability. Operating systems must work across diverse hardware configurations and support a wide range of software applications. Compatibility ensures that software designed for previous versions continues to function on newer OS releases. Portability allows the OS to run on different hardware architectures with minimal modifications. Backward compatibility means legacy API support for older applications, binary compatibility layers for previous versions, and emulation of deprecated hardware interfaces. Cross-platform support includes hardware abstraction layers, platform-independent system calls, and standardized driver interfaces. Interoperability has support for common file systems and formats, network protocol compatibility, and cross-OS communication mechanisms. Let's explore efficiency and resource management. Operating systems must optimize the use of limited hardware resources while meeting performance requirements. For CPU management, we have scheduling algorithms, process prioritization, and load balancing. Memory management includes virtual memory systems, paging and swapping, and memory allocation strategies. Storage management includes file system optimization, caching mechanisms, and input-output scheduling. Power management includes dynamic frequency scaling, sleep states, and component power control. Network resources includes bandwidth allocation, connection pooling, and protocol optimization. Resource allocation has fair sharing algorithms, resource reservation, and quota enforcement. Operating system design involves making trade-offs between competing goals to create a balanced system that meets the needs of its target users and use cases. Performance means speed and efficiency. Security means protection and privacy. Usability means ease of use. Reliability means stability and recovery. Compatibility means support for apps. Balanced OS design is optimizing trade-offs for specific use cases. Here are some examples of trade-offs: security versus performance, usability versus security, compatibility versus innovation, and simplicity versus functionality. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.